Okay, our lesson for today's discussion is all about the fineness of cement. And to start with, let us have first the definition of fineness of cement. The fineness of cement is a measure of the size of particles of cement and is expressed in terms of the specified surface area of cement. The fineness of cement is measured as the percentage weight retained on a 90 micrometer IS sieve over the total weight of the sample. And followed by, which apparatus is used to measure the fineness of cement? And we have the Blaine apparatus. Fineness test is performed on the Blaine apparatus. It is practically a manometer in the YouTube form. One arm of the manometer is provided at the top with a conical socket to form an airtight pit with a conical surface of the cell. Here is now our Blaine air apparatus sample. This is now what we call the Blaine air apparatus, to be followed by its different parts. Blaine air apparatus is consisting of the following parts: the manometer, the conical socket, the stopcock, edge lines, rubber bulb, perforated disc, permeability cell, and the flanger, including the compacted cement bed. How do you calculate fineness modulus? After the sieving process, record the sample weights retained on its sieve, then find the cumulative weight retained. Finally, determine the cumulative percentage retained on its sieves. Add all cumulative percentage values and divide with 100, then you will get the value of fineness modulus. What is fineness of cement by dry sieving? The fineness modulus of a cement is an empirical figure obtained by adding the total percentage of the sample of an aggregate retained on each of a specified series of sieves and dividing the sum by 100. We have now the following apparatus when performing the fineness of cement. We have the balance, the sieve shaking machine, the tray, the brass trowel, tamping rod, sieve lid, and of course our material, we have the cement. The fineness of cement by sieve analysis is measured by sieving it on a standard sieve. The proportion of the sample of cement of which the grain sizes are larger than the specified mesh size is thus determined. A reference sample of cement having a known proportion of material coarser than the specified mesh size is used for checking the specified sieve. How do we calculate now the fineness of cement? It can be calculated by using air permeability method or by using sedimentation method or from particle size analysis. We call it also as the sieve analysis. Dry sieving measures the cement particle size, whereas air permeability method and sedimentation method measures the specific surface area of cement. Here we have explained about the particle size analysis of cement. Why fineness test of cement is done? In almost all cement tests, the fineness test of cement is to be determined. Fineness test is used in checking the proper grinding of cement and measuring the surface area of the cement particles per unit mass. As well as fineness of cement increases, the requirement of water for workability also increases, which results in a higher possibility of dry shrinkage. The fineness of cement by sieve analysis as per IS 4031 Part 1, year 1996. The IS code for fineness of cement test by sieve analysis, known as IS 4031 Part 1 of year 1996, for determination of fineness of cement. And we also have the other references as IS 460 Part 1 of 1985 for specification of sieves, IS 3535 of year 1986 for methods of sampling hydraulic cements. And of course, we also have the IS 5165, year 1969 for interchangeable conical ground glass joints. The apparatus used for fineness test of cement by sieve analysis are the following. The 90 micrometer IS sieve with a pan as per IS 460, the sieve lid, weighing balance capable of weighing up to 100 grams to the nearest 10 milligrams, a nylon or pure metal brass, Gauguin trowel, the tray, the tamping rod, sieve shaking machine. This is just an optional apparatus if you only have. The fineness of cement sieve size. The size of sieve used in finding fineness of cement is 90 micrometer IS sieve with pan as per IS 460. It comprises a firm, durable, non-corrodible, cylindrical frame of 150 millimeters to 200 millimeters nominal diameter and 40 mm to 100 mm depth, fitted with 90 micrometer mesh sieve, cloth of woven stainless steel or other abrasion-resisting and non-corrodible metal wire. The material for checking the sieve. A standard reference material of known sieve residue shall be used for checking the sieve. The material shall be stored in sealed, airtight containers to avoid changes in its characteristics due to absorption or deposition from the atmosphere. The container shall be marked with the sieve residue of the reference material. Sampling and selection of test specimens. The samples of the cement will be taken according to the requirements of IS 3535, 1986 methods of sampling hydraulic cements, and the relevant standard specification for the type of cement being tested. Mix thoroughly the representative sample of the cement, selected as above before testing. Let us now proceed to temperature and humidity. The temperature of molding room dry materials and water will be maintained at 25 degrees Celsius to 29 degrees Celsius. The relative humidity of the laboratory will be 60 to 70%. The moist closet or moist room will be maintained at 25 to 29 degrees Celsius and at a relative humidity of not less than 90%. Procedure of fineness test of cement by sieve analysis. Agitate the representative sample of the cement to be tested by shaking for 2 minutes in a stopper jar to disperse agglomerates. Wait for 2 minutes and stir the resulting cement powder gently using a clean dry rod in order to distribute the fines throughout the cement. Procedure number 2. Accurately weigh 100 grams of cement for test sample to the nearest 0.01 gram and place it on the sieve, being careful to avoid loss. Then we will have the total weight of cement, W sub 1. Rub the cement particle well with your fingers so that no air set lumps are left and agglomerates are dispersed. Fit the lid over the sieve. If you have a sieving machine, then you just need to put the sieve in the sieving machine and start the machine for 15 minutes. If you don't have the sieving machine, then no problem. You can shake it also with your hands. Hold the sieve with a pan and in both ends and sieve with gentle whisk motion in circular and vertical motion for a period of 15 minutes without any spilling of cement until no more fine material passes through it. Then for the seventh one, place the cover on the sieve and remove the pan. Now tap the other side of the sieve with the handle of brass and clean the outer side of the sieve. Now weigh the retained amount of cement on the sieve, the weight of cement sample left on the sieve. This is now our W sub 2. Empty the pan and fix it below the sieve. Repeat the whole procedure at least 3 times using a press 100 grams of sample of cement to be tested. Totally sieve for 15 minutes and weigh the residue, the weight of cement left over the sieve. For the 13th step of our procedure, calculate the fineness of cement by formula W sub 2 over W sub 1 to be multiplied by 100% for each time. Then express the fineness of cement as the average of the three values. Then check the sieve after every 100 sieving. For our observations, we have to list down the following: the weight of cement taken, the weight of cement retained on the sieve, the type of cement, the brand of cement, and the room temperature. And as shown below is our table for the observation table for fineness of cement. We have trail number 1, trail number 2, and trail number 3. For our observations, in this column, we have the weight of the sample, weight of residue of cement, the percent of fineness cement, the weight of residue of lye husk, and percent of fineness of lye husk. So we have to fill in this given table as shown in this slide, the observation table for fineness of cement. For the calculations, this is now the formula for fineness of cement by sieve analysis. And we have W sub 2 divided by W sub 1 to be multiplied by 100%. And for the result, we will be having now the fineness of the given cement sample in terms of percent. In terms of limit, for the good quality cement, the amount of cement retained on the 90 micrometer sieve will never exceed 10%. The fineness of cement should be lower than 10%. And that is actually the standard. For the report the value of the fineness of cement to the nearest 0.1% as the residue on the 90 PM sieve for the cement tested. The standard deviation of the repeatability is about 0.2% and of the reproducibility is about 0.3%. For the safety and precautions while testing, clean the apparatus thoroughly before testing and after testing. The test should be performed away from vibrations and other disturbances. Wear helmet, shoes, and hand gloves during the test. The weighing should be done accurately. Make sure that the sieving operation is done in all the directions for a minimum of 15 minutes. Sieving will be done holding the sieve in both ends and gentle wrist motion. This will involve no danger of spilling the cement, which will be kept well spread out on the screen. More or less continuous rotation of the sieve will be carried out throughout sieving. Washers, shots, and slugs will not be used on the sieve. The underside of the sieve will be lightly brushed with a 25 or 40 millimeter bristle brush after every 15 minutes. After every 5 minutes of sieving. Mechanical sieving devices or sieve shaking machine may be used, but the cement will not be rejected if it meets the fineness requirement when tested by the hand method. What is the degree of fineness of cement? It is actually a measure of the average size of the grains. The finer cement has quicker action with water and gains average strength without change with the ultimate strength. Finer cement is susceptible to shrinkage and cracking. What is the unit of fineness of cement? It is a measure of the size of cement particles. In sieve analysis of cement, fineness of cement is calculated by ratio of weight of sample or cement sample retained on the sieve with the total weight of cement sample. Thus, there is no unit of fineness of cement. While in the air permeability method or sedimentation method, the fineness of cement is expressed in terms of the specific surface area of cement. The specific surface is expressed as the total surface area in square meter of all the cement particles in 1 kilogram of cement. Thus, the unit of fineness of cement is square meter per kilogram. Higher the specific surface, the finer the cement. Why fineness of cement test required? Why do we have to require it? We know that cement hydrates when cement is mixed with the water and a thin layer are formed around the particle. This thin layer grows bigger and makes cement particles separate. Because of this, the cement hydration process slows down. On the other hand, cement smaller particles react much quicker than the larger particle. A cement particle with a diameter of 1 micrometer will react entirely in 1 day, whereas a particle with a diameter of 10 micrometer takes about 1 month. But there is a side effect of having too much smaller particles in cement results in quick setting, leaving no time for mixing, handling, and placing. Therefore, to increase the setting time of cement, it must be manufactured in a different range of particle size. The fineness of cement test measures this parameter of cement. The fineness test of cement, the AIM or AIM, is to determine the fineness of cement by using 90 micrometer sieve as per IS 4031, Part 1 of your 1996. And again, as a summary, these are the apparatus that we have to use: the sieve lead, the sieve shaking machine, the 90-meter or 90 micron sieve or micrometer sieve, and the weighing balance for the fineness test of cement. And of course, we have the cement itself. The 90 micrometer IS sieve, weight balance, having a capacity of 10 milligrams to 100 grams, nylon or pure crystal glass. The fineness test of cement procedure, again, I repeat. First, you have to collect a sample of cement and rub with your hands. The fineness test sample should be free of lumps. Take 100 grams of cement sample and note its weight as W1. Drop 100 grams of cement in 90 micrometer sieve and close it with a lid. Now shake the sieve with your hands by agitating the sieve in planetary and linear movements for 15 minutes. After that, take weight the retained cement on the 90 micrometer sieve as W2. To calculate fineness of cement formula is given now below. W2 over W1 times 100% is our formula for the fineness of cement. Then calculate the percentage of weight cement retained on sieve. Repeat this procedure with 3 different samples of cement and average the values for accurate results. The fineness of cement calculation that we have now, the table shows the fineness of cement value. We have the SR number for the first column. Second column, we have the weight of cement sample, the weight cement sample retained on 90 micrometer sieve, and with the last column, we have the fineness of cement. As we can see below, that the average is 6.95% for the fineness modulus of cement, and this is actually pretty less than 10%, meaning the result, the standard value of fineness of cement should have fineness less than 10%, or fineness of cement should not be more than 10% as per IS recommendations. The size of the sieve used to test fineness of cement is, the size of sieve used to test the fineness test of cement is 90 micron IS sieve. What is the value of fineness of cement? Generally, cement used for construction should have value of fineness less than 10%, meaning if it is less than 10%, that is a passing rate. Why fineness of cement is important? Cement smaller particles react much quicker than larger particles. A cement particle with a diameter of 1 micrometer will react entirely in 1 day, whereas the particle with a diameter of 10 micrometer takes about 1 month. If fine cement particle is more in cement, then it will be set too quickly and that not feasible on site to place concrete properly. The fineness of cement is a measure of cement particle size and is denoted as terms of the specific surface area of cement. The weight of cement particle whose size is greater than 90 microns is determined and the percentage of retained cement particle are calculated. This is known as the fineness of cement. That's the end of our discussion. Thank you very much and God bless us all.